Hi guys, what's going on? This is Samuel from TechWithSam again. In today's video, we are going to be diving into something interesting that is on-device AI. So we are going to be building something with TensorFlow Lite. It will be like a tutorial on building image classifier that recognizes objects in real time. So it will be like when you pick an image from your gallery or camera, so it will be able to classify image from your gallery or your camera basically. So we'll fix some common setup error and also get it up and running smoothly on Android and iOS. So this is pretty simple. By the way, I've built this project before recording this video, so I'll just be doing explanation and also displaying how the app works like that. So we will use mobile net. Mobile net is like quantized for mobile. We'll download the TFlite and the model and also some little bit test. The link will be in the description to get it up and running. So that's pretty much it. So now let's just get straight into the video. By the way, if you're here and you're yet to subscribe to the channel, make sure you do that now, like the video, and also drop an honest comment in the comment section below. Yeah, so this is my pop spec. So these are the packages that you'll be needing. Flutter report is basically for state management. Google Fonts basically for fonts. So this is the major package. Camera, so camera is just to have the camera feature that is recording live. We have the image picker, so you can pick from your gallery. You have the TFlite Flutter. This is the package itself that we'll be using. That's the TensorFlow Lite, the Flutter plugin. It's from the TensorFlow organization itself, so you can see it. That's what we'll be using. Then we have the path provider permission handler to just undo all the other permission, and that's pretty much it. So the next thing now on this prospect is our assets folder. If you remember, I mentioned that we'll be downloading some files, so the link will be in the description so you can download the two files. But here's how it looks like. So basically you have to put these two files, the mobile net TFlite file inside the assets folder. So I create a folder, assets, then models. So this is the labels.txt and the mobile net the text. So if you open the label, so you can just see it is a bunch of text basically. So the link will be in the description so you can download it from there. So these are the two files that is required because our TFlite will be reading these two files to get an accurate data for us basically. Yeah, all right. So now the next thing now is to move to setup. So after you have installed the package, there's some basic setup that you just have to do. So on iOS there's nothing much, but on your pod file you just have to upgrade this to 15 so it can run some of the packages that you have installed. So just change this to 15 and you are good to go. So just run pod install and you're good to go. Yeah, that's pretty much it. And for Android, although I didn't run this app on Android, but I'm pretty sure that you have to update the minimum SDK and probably the target SDK to probably 24 and 34 respectively. So just try and run it, then you should, if you get any error message, the error message will be explanatory on which one to upgrade here. So that's pretty much it on these two installation guide. So that's that on this setup. So there's no other setup that is required for Android and iOS, and now we can just go straight to the coding aspect. So inside my lib folder I just have the source folder here. So the source folder basically just contain the provider for state management, the services where we are performing all the functionality. So this is the provider. So the app, as I mentioned, is a classified. It classifies objects basically. It tells us what the object is all about. So it will give it in percentage, like, oh, this image is this, and also that's basically it. So we have our UI where we are just presenting the screen. I mean this particular screen. Yeah. Then our main.dat. So let me just start with main.dat. So main.dat pretty straightforward. So this is our entry point. Since we are using RoboPod, that's why we are using provider scope here. So don't forget to initialize your Flutter app. Yeah, so that's pretty much it. Then the material app of our app. So let's go to the home screen. But before we go to the home screen, let's just go to the functionality first. So inside our provider, where we have the classifier provider. So this is pretty straightforward. So this is just like creating a provider class just to hold it's just like creating an endpoint class. So this is our TFlite service provider, so we can have access to it on our home screen. Then the classifier initialize provider as well. So this one watch everything that is happening, because inside our TS service, that's where we'll be performing all the functionality. It's just like integrating an API basically. So that's what we are doing here. So we have the TF service provider that watch this TFlite service. Then we have the classifier initialized provider as well. Yeah, so that's pretty much it. So inside our service folder now, here we have the TFlite service. Then this is where we are doing all the major works. So this is where the functions are. So also, if we go through the documentation of this particular package, you you understand some of the reason why some of these things are done this way. But let me just go through it so we can just have some overview about it. Yeah, so after creating a class, then we have the interpreter. So the interpreter is basically, as the name implies, it to interpret the objects and the label. So this we are just trying to fetch the response from the interpreter. So we are storing it inside a list because it will be more than one. So if we pick an image now, we upload it, it will fetch different responses. So we are storing everything inside the label. So we have is busy. So this is busy is just to check if the interpreter is none or not, and pass if we are getting any response basically. So that's pretty much it. So we have this input size. So by default, we have some input size. If we go through the documentation here, so we have different input size. Yeah, so we just set it to 224 by default. Yeah, so that's the input size of any input that we are getting. So that's pretty much it. So inside our initializer, in the initializer function, basically we are reading the two asset files that we have. So the mobile net and also the labels. So the first thing is getting the interpreter. So the interpreter will interpret from this our asset. So keep in mind, everything still work with these asset files. So if they are not present, then this won't work. Yeah, because they are all reading from these two files. So it's all on TensorFlow website, so you can just check it out. Yeah, so also the link will be in the description as well. So after interpreting the image file here, we are able to get fetch everything that is inside this mobile net. Then it will get the data. Then we have our label as well to run through this label the text file. Then we get the data as well. So after we are able to initialize these two files, we know that our model is loaded successfully, so we can use this to interpret an image and get we can use it to classify an object basically. So that's that about initialize. Then the next thing is classify image. So this is from image picker. When you pick an image, this we use to interpret the image basically. So the first thing we are checking, if the interpreter is none, if you're not getting any response, then you should just return empty list for this our label. Otherwise we should check through it and read it as bits, so we can the classifier basically we check through the image, probably check to image is in pixel, so to check through the pixel and see the matching identity basically, like it will classify the image node. So after that, then we can run inference. So the inference function is still at the bottom, so we'll go through it in the next couple of minutes. So that's that for classify image. So after that, now the next thing is to the camera image as well. So we have the camera, although I won't be able to test the camera here because I want simulator, the camera won't work. But the camera, now we can pick an image live and we can get a response from it. We can classify the image in a live camera. So that's for classify image. So that's why we have all this functionality. So we just convert the logic from camera image to the image file. So that's pretty much it. Then the next thing now is the inference that we have here. So the inference basically is the major part of this project. This is where we are interpreting all the image, getting the response, the label for the image. So this is where we are getting the labels basically. So there's some bunch of code here that might not really get, but it's part of the documentation. So we're just running some bit command. If you check through the inputs that I mentioned that we set to default to 224 yeah, so this is the input. So for example, if input tensor shape is 105 and type is float 32, so these are just some of the input and output that we have here. So we as well classify it here. So we create an input file, then we resize the image. After resizing the image, then the input size, the default one that we have, then the other input that we just classify here basically. So it will run the inference on the image and get the probability. I mean, to classify the image and get the nearest probability of that, the meaning, I mean the interpretation of that image basically. Yeah, so after doing that, then we can run through some for loop and check through the probability. So the stuff is actually fetching from this label, so it will run through this label and check through the matching order or the matching compatibility to see if it actually match what it is on this particular label or text. So it will, once it match, as you can see, if the probability is greater than 0.05, then it will add it to our result. So it will result.add. So the label will be label here, then also the confidence. So we can see the percentage, like the confidence of the AI model or the machine model saying, okay, I'm sure that this particular update is this. So we can see the percentage. So for example, if I upload an elephant image, the confidence can be like 100% or 72 and thereabout. So it should also get the image, like all the labels rather. So that's pretty much it about this part. So after that, then we return the results basically. So I think the marks for it is 5, that we set here to 5. So the label will just be 5. So we can see the list under here and also the confidence. Yeah, all right. So the next thing now is the image to bit list float 32. So this particular function basically is just converting an image to bit, so it can like fetch, it can actually read through the image basically. So that's what we are doing here. So after converting the image, then we can use it. If you check, we used this function image to bit list float 2 here. So that's where we actually use the image. So we just convert the image to bits here, so to be able to use it in the inputs here. So that's that. Then the next is to convert camera image. So camera image from the image group. So this is just a function from the this package that we installed, the image package that we installed earlier. So we are just converting the image. So after that, we can just use it inside our input as well. So that's pretty much about this camera image. Then convert to image as well. These are just bunch of functions, so it can, these are just bunch of functions. So the machine learning can actually read the data set from that image in order to get the required object or the required label and the confidence level as well. So that's why we're just converting the image, so we can get each element on that image basically. So these are the functions. So if you check through this image package, you can get some of these functions. So that's about converting the image. So we convert the image to 3 image types, so you can as well get the best result value for it here. So that's that. So the next thing now is in our UI. So after running through the function, so basically what we are doing basically here is getting the interpreter. So the interpreter will interpret the image, and after the interpreter fetch through the image, we are adding all the results to this label. So the result will be added to this label. Then on the UI, what we are just checking is the label. So the image, we have different label, and the max is 5. So it will have a confidence level that is okay. The ML is confidence that this image is this particular object or this particular name or whatsoever, then it will like present it to us. So that's pretty much it. Then this image converter basically is to convert the image and like classify the image in different group to get the best precept of all these images. So yeah, that's pretty much it. So after that, now we can just go to our home screen. So in our home screen now, this is the home screen here. If you can see my simulator, so this is the home screen. So we just create home screen basically. Then we have the file for image picker, we have the results. So this is all the results. We can check if it's on camera mode as well. Like if you click on this camera icon, so you can check if it's on camera mode. Then we have the image picker constructor here. So this is image picker function, just to pick an image from gallery. So then our classify image, so we are reading from the our service provider, which is from this. So this is listening to the service for class, which is this. So that's what we are doing here. So it will reach, then get the results. So after calling the classify image, so the classify image function that we have here, so it's this classify image, so it will run through it again, get the result basically. So classify image, after submitting the file that the user picked, then we add it to the results. So that's that about this classify image. Yeah, so this is just the screen. So this screen basically, we're just presenting the image the user picked there, then the confidence level that we have here. So for example, now let me just run through a test. So if I pick an image, so let me just click on my pick image button. Okay, give me a few seconds. Right, let me pick this. Okay, alright, it's still loading. Okay, so now you can see the response. So we have the confidence level now. So you can see worker old. So this is like the name of the object here. You can see the confidence, which is 36.9. We can see another possible output, or we can see different possible output. If I pick another image, let me pick something. Yes, let me pick this. Yeah, let me pick this fountain. Yeah, okay, so you can see now that the fountain, you can see the confidence level, which is 89. Fountain, you can see the confidence level and the next thing. Yeah, so this is just like what the result will be like. So let me pick another image. Let me pick this. All right, so you can see it's classifying the cliff as the highest confidence level as well. So that's pretty much it about it. So as you can read in this function also, the upper part is where we can like move to camera mode. So this camera mode will capture live object and classify it. Then we have the body where we are reading the data. So this is river pod. So we have the data loading and error. So on data now, we are checking if it's on camera mode. If it's on camera mode, then we have the camera view widgets here. So this camera view widgets, now we can run like live classifying objects. So we can classify objects live with the camera mode. Yeah, so that's that. So if it's on camera mode, that's why we set a variable here if it's on camera mode or not. So we can use it here as well. So if it's on camera mode, then and if it's not, basically, so that's then. Oh, okay, this way. So if it's on camera mode, you shoot to the camera view, otherwise the gallery view. So this is the gallery view. For camera view, it's different here. So that will capture the objects live. Yeah, so the next loader, then the error. So our floating action is to pick the image from our gallery basically. So this is the gallery view, what we are seeing here right now. Yeah. So that's the camera gallery view rather. Yeah, so that's pretty much it about that. So the result as well, this result that we are seeing here, so it's just building the results here, so you can just tweak it to your own niche. So this is actually a fun project, so you can just test it out on your Flutter app. If you are building something amazing like an AI project or something like that, and you want to like fetch, or you are even working on, let's say, an agriculture app where you want to read the status of a particular plant, probably the plant is LD and all sort of thing, you can use this as well to capture the current state of that plant or any object whatsoever that you want to work on, you can use this kind of feature or this kind of project to actually accomplish that. So that's pretty much it for the camera view. I won't be able to like present the UI here, but the camera view, basically we're using the camera package to run through like the front camera. So on live mode, it will initialize the camera, then capture what the image is capturing. I mean, when we snap an image, it will just run through it, then give us the possible result and also the confidence level, so you can know that, oh, this machine is pretty sure that this is the results. So with the confidence level, basically. So that's pretty much it. So let me just do a few tests here. Let me pick another image. Let me pick this guy here, so you can see okay, so you can see the confidence level. Say microphone sucks. I don't know where this guy gets sacked from, but that's AI for you. Let's pick this kid. Yeah, so you can see for code stole neck brace. Okay, so let's pick another object. Let's pick this guy. Okay, you can see Jesse notebook lab codes. All right, so these are just some of the responses that we'll get from this our TensorFlow Lite using the mobile net functionality that is available publicly. So that's pretty much it. Let me know what you think in the comment below. If you have any other suggestion or how best to as well use this package, or one of the best feature you can use, or if you have any project in mind you want to use this kind of project for, let me know in the comment, and I will see you in the next video. Bye.